Hello, friends. In the previous class, we have seen a lot of general about the monocyclic neutral systems, and it is very important to study one of the monocyclic systems in detail. Let's take up the only compound which shows anti-aromaticity and is the first member of the series, that is cyclobutadiene. Cyclobutadiene is a cyclic four-membered compound which has four p orbitals and four pi electrons. Now, it is anti-aromatic and it is unusually unstable. Let's see the details of it. Cyclobutadiene is supposed to be a square, but the geometry is not a square. Instead, it's more of a rectangle due to the difference in carbon-carbon single and carbon-carbon double bond. Usually, it is drawn wrongly as a square. Now, carbon-carbon single bond length comes to be 1.567 angstrom, whereas carbon-carbon double bond length comes to be 1.346 angstrom. And this difference in bond length assign a rectangular shape to cyclobutadiene. Now, to illustrate the aromaticity of cyclobutadiene, the energy levels of the compound are superimposed on a square with the vertex pointing down. Yes, that's right. I'm talking about the frost circle. So let's see the frost circle distribution in order to explain the aromaticity of this compound. As we can see that there are two valence orbitals in the compound are present in the non-bonding orbital area. Now, because there are two vertices which touch the frost circle at the non-bonding line. These are singly occupied and there are two electrons in the bonding region. So this distribution of electrons helps to explain the unusual instability of cyclobutadiene, and that means this explains the anti-aromatic nature of this compound. So it was first synthesized by oxidative degradation of cyclobutadiene iron tricarbonyl. That is the metal carbonyl organometallic compound with its treatment with ferric ammonium nitrate. And when the four-membered ring got separated from iron complex, cyclobutadiene reacted with electron deficient alkynes and finally it formed benzene due to internal distribution. Cyclobutadienes are, as we have seen, they are unstable and the compound dimerizes at a temperature above 35 Kelvin by Diels-Alder reaction. Now, Diels-Alder reaction, as you people very clearly know, that it is a chemical reaction between a diene which is conjugated and a dienophile, that is a substituted alkene. And this forms a substituted cyclohexene derivative. So this Diels-Alder reaction is an example of pericyclic reaction which proceeds further in a concerted fashion. Pericyclic, what is a pericyclic reaction? You have studied in your earlier semester that pericyclic reaction is a type of reaction where the intermediate state of the molecule has a cyclic geometry and it moves further in a concerted fashion. Now, concerted fashion means that the chemical reaction in which all the bond breaking and bond making and whatever rearrangement have to take place, they take place in a single step. So reaction intermediate, yeah, otherwise the unstable high energy intermediate, no such intermediate is involved. That is concerted fashion. Activity of cyclobutadiene complex. Usually, cyclobutadiene as a complex, as a compound, not as a complex, as a compound only gives dimerization reaction that we have earlier also gone through that. But as complex, which we studied earlier also during the synthesis, shows so many reactions. So the unfused cyclobutadiene system is stable in complexes with metals. But in these cases, electron density is withdrawn from the ring by the metal. So the compound undergoes aromatic substitution, and your NMR spectra of this monosubstituted derivative, the all the derivatives as you can see are monosubstituted. So the NMR spectra of these monosubstituted derivatives indicate that C2 and C4 protons are equivalent. So at this stage, when the electron density is withdrawn from the ring towards the metal, then the ring becomes square planar. Earlier, I had told you according to the bond length and those patterns, the shape the ring had taken was more of a rectangle. So these are the certain reactions of the iron carbonyl, and as you can see in all of these reactions, the substitution takes place at only at the same position, varying according to the different reagents that the compound is subjected to. So that is the chemical activity of this compound. So, my friends, I hope you must have followed the concerned topic, and in the next class, we shall take up something new. Hope you are enjoying this learning experience. Do tell me your queries in the comment section. See you in my next class. Thanks for watching. Bye bye, everybody.